All right, this is the ticket activity that we did in class and a review for the test over 4.4 to 4.6. So again, on this, the first one asks us to factor it. Remember, if there are four terms, we want to try it by grouping. So I'm going to group the first two together, and then remember you want to put plus and keep that negative sign inside the parentheses. Then we take out the greatest common factor, which is x squared, and we get x minus 1. And then here we can pull out a negative 9, and again we get x minus 1. Again, the key is to get those same factors on both. So now I'm just going to go up here, I'm going to pull an x minus 1 out. And then, so those cancel, and we have x squared minus 9 left. And so that goes next. And then again, anytime you have a squared, you want to see if you can factor that further. And this is the difference of two squares because it's minus, and I can take the square root of both. So that ends up being x minus 1, and then the x squared minus 1, or minus 9 factors into x plus 3, and x minus 3. And so that is the factored equation. The next one, we want to check for greatest common factor, and I can pull a 3 out of that and get x cubed plus 216. And then again, because it's cubed, we want to look and see are there any cubes in this. And if you check your sheet of cubes, obviously we can take the cube root of x cubed. And 216 is 6 to the third power. So I can rewrite that now. Remember, the shortcut is the 3 is going to stay there. Then it's a plus b, so x plus 6. And then a squared, so in this case x squared, minus ab, which would be bx times 6 would be 6x, and then plus b squared, which is 36, and that factors into that. If we go over to number 2, again, the first thing we should always check for is greatest common factor. In this case, I can pull a 6x squared out, and then I get x squared plus x minus 2. It's a quadratic, so we should try the x method. So we get negative 2 and 1, so that would be 2 and negative 1. So that factors into x plus 2 and x minus 1. And that's our answer there. The next one, again, it's a cube, so we want to check the c. In this case, if we check your list, I can write 64 as 4 cubed. And so in this case, our a is x and our b is 4. And so it's x minus 4. And then x squared, and then plus a times b, which in this case would be 4x, plus b squared, which would be 16. And we have that factor. The last factoring set on ticket 3. So again, I'm going to check for greatest common factor. I can pull an x out, and I get x cubed plus 3x squared minus x minus 3. It's 4 terms, so I'm going to try and group that. So I still have that x out front. I'm going to group the x cubed and 3x squared together, plus, and then negative x minus 3. I can pull an x squared out of those. So if I pull an x squared out, I get x times x squared. Well, let's just go. I'm going to keep that x. I'm going to get x squared, and then x plus 3. I'm going to pull a negative 1 out of this to get that negative out of there. So negative 1, x plus 3. So I'm going to go up here. Again, I have the x still out front. That's going to stay there. And then I share an x plus 3. And then I get an x squared. So those are gone, and I have x squared minus 1. And then because that's a quadratic, we should check it, and that fits the difference of two squares. I can take the square root of both. And so I still have that x and the x plus 3, but the x squared minus 1 factors into x plus 1 and x minus 1 for our final answer. The last one on factoring, it says 4x squared minus 49. And so again, since it's 2 terms and it's minus, I check. I can take the square root of 4x squared, and I can take the square root of 49. So that would factor into 2x plus 7. And 2x minus 7. Now you could use the x method on that, but you would have to factor it and then put the box in because a is not 1. So ticket 4. Now they ask us to find the zeros, and they tell us that one of the zeros is x equals 2. So remember, if we know that, we're going to use synthetic division. And because it's 2, we'll just put the 2 there. So 1, 5, negative 10, negative 8. Remember, if it ever skips the power, you have to put a 0 down. So I bring down the 1. 2 times 1 is 2. 5 plus 2 is 7. 2 times 7 is 14. Negative 10 plus 14 is 4. 2 plus 4 is 8. And so now we have, remember, constant, first power, second power. Now this, you could try and do the x method, but there are no factors of 4 that add up to 7. So when we have that case, we have to use the quadratic formula. So our a is 1, our b is 7, and our c is 4. So we get negative 7 plus or minus 7 squared, 49, minus 4 times 1 times 4, all over 2 times 1, which is 2. And then we're going to take 4, we have 49 minus 4 times 1 times 4 is 16. And so we get negative 7 plus or minus the square root of 33 over 2. There's no perfect squares in 33, so that is 2 of my answers. And then remember, we had the 2, so that is the third answer. So ticket 5, again, same type of thing. Again, in class, I don't care if you graph these, you can always use the Desmos to put on the graph. So now they give us x equals negative 1. But the first thing I check for here is I can factor an x out of this. So I'm going to pull an x out and get x to the third plus 3x squared minus x minus 3. So I know already this is a 0. So 1, 0. We're going to have one answer that's 0. We know that negative 1 works, so I'm going to do negative 1, synthetic division. So that's 1, 3, negative 1, negative 3. 1, negative 1, 2, negative 2, negative 3, 3, 0. So remember, constant, first power, second power. So we have x squared plus 2x minus 3, which factors into x plus 3, and x minus 1. And so we have a 0 for an answer. We had negative 1 for an answer. We get, remember, it's the opposite of this, divided by the number in front. So negative 3 and positive 1. And so we have our 4 answers. Next one, again, I don't care about the graph. We know negative 2 is a 0, so I'm going to do synthetic division with negative 2. So 1, 6, 11, 6. 1, negative 2, 4, negative 8, 3, negative 6, 0. Constant, first power, second power. So x squared plus 4x plus 3. Do the x method, but that factors into x plus 3 and x plus 1. And so our answers are the one they gave us, negative 2, opposite this, negative 3, opposite 1, negative 1. So that's the factoring. So now they don't tell us on this one of our zeros. So now we have to use that p over q. And so remember, p is the factors of your constant term, 3. So that would be 1 or 3. And your factors of q are your leading coefficient, which is 1. So that's 1. So our possibilities are plus or minus 1 and 3. And then you would want to use the Desmos calculator. So if we use the Desmos calculator, use the Desmos, you get that it crosses at negative 3, negative 1, and 1. So we can do synthetic division with any of those. I'm going to go ahead and do it with 1. 1, 3, negative 1, negative 3. So 1, 1, 4, 4, 3, 3, 0. And so we have 1. 1 works. And then again, constant, first power, second power. So x squared plus 4x plus 3 factors into x plus 3 and x plus 1. And so we get negative 3 and negative 1. Again, you could have used any of those to do the synthetic division with, but it doesn't make any difference. You'll still get the same answer. On ticket number 8, they want you to identify the number of zeros. The key point is to remember the highest power tells you how many zeros you have. So our highest power is 6. So we have 6 here. This isn't in standard form, but our highest power is 5. So we have 5 zeros there. Highest power here is 2. So we have 2. Now this one's a little bit different, because this x plus 2 squared would give me x plus 2 times x plus 2. But remember, how many? We have 0 here, 1 here, and we have 2 here, so we know we have 4 zeros. Okay, without even having to multiply that out. On ticket number 9, these are fairly easy. It says identify the number of imaginary zeros, and it says the degree is 4. So if the degree is 4, we should have 4 solutions. But we only have it crossing in 2 points, so that means we have to have 2 imaginary solutions. Here our degree is 3. We only have 1 answer, so again we would have to have 2 imaginary solutions. And on 11, our degree is 3. We have 1, 2, 3 zeros, so we have them all. So that would be 0 imaginary solutions. And then the last part is the most difficult part on the whole thing. It says construct a polynomial with 5, 9, and -1 as the only zeros. So I'm going to do this here so I have more room. We know we have zeros at 5, 9, and -1. So remember, if 5 is my answer, I had a factor of x minus 5. And therefore, if I have 9, I have x minus 9. If I have -1, I have x plus 1. So I have to multiply this together first. So x times x is x squared, minus 9x, minus 5x, plus 45. I'm going to add my like terms. And now I'm going to multiply that by x plus 1. So now x squared times x is x cubed. X squared times 1 is x squared. Negative 14 times x is negative 14x squared. Negative 14x times 1 is negative 14x. 45 times x is 45x, and 45 times 1 is 45. Combine our like terms, x cubed. X squared minus 14x squared is a minus 13x squared. Minus 14 plus 45 is a plus 31x. And then we have plus 45. And so that would be our function. All right, the next one. We have zeros at 0, -3, and -3. So we have that -3 occurs twice. So we have 0, -3, -3. So if you have 0, it's just x. And so this will be x plus 3 and x plus 3. And so we get x. I'm going to multiply these two together first. X squared plus 3x. 3x plus 9. And so we get x times x squared plus 6x plus 9. And so we get x cubed plus 6x squared plus 9x equals f of x for our function. And then the last one, we have construct a polynomial with 1, 2, and 3 as the only zeros. So 1, 2, and 3. So that would be x minus 1, x minus 2, and x minus 3. So again, I'm going to do this one first. X squared minus 2x minus x plus 2, which is x squared minus 3x plus 2. And then times that by x minus 3. X squared times x is x cubed. X squared times -3 is -3x squared. We get another -3x squared. -3x times -3 is positive 9x. And then 2x minus 6. Combine like terms. X cubed minus 6x squared plus 11x minus 6 equals our function. So that's the review of that. Hopefully that helps you for the test.